Okay, so in this video, I'm be doing the chi-square goodness of a statistic. So now that I did an experiment. Well, not an experiment. Well, I did a whole scenario on like WhatsApp groups to analyze what is this now. What to explain simply what this chi-square goodness of a test is. It's basically testing a theory. For example, if people said 50% of people in this group is right-handed, we via this goodness of a test basically is trying to say, is this accurate? Because there's a lot of theories in this world, so we need to find out if they are accurate. So the way they do it is conduct a goodness of fit statistic. Now the first thing over here which I want to show you is to look and analyze. So in a WhatsApp group quiz, people were asked to guess the amount of people who were left-handed versus right-handed. So they were asked, what do you think? How many people were right-handed and left-handed? So the results were as follows. So 11.5% said they were left-handed and 88.5% said they were right-handed. So now this is what they thought. This is the theory. This is the expected. So just now we'll do a table. So these are come from the expected. So expected is the theory. Now doing a quiz. So this was a quiz conducted after, which to ask the people, are you left or right-handed? Now the actual number of these people was as follows. People that are right-handed is 71 and people that are left-handed is 10. So what will this be? This will be the observed, right? Observed data. So now that we got this, I want to do the write down the null hypothesis and hypothesis alternative. So the null hypothesis. Now to write null hypothesis, we put H0. So the null hypothesis is very easy. What is theory? Now to write this theory down, we can say P1 is equals to 0. Let's see. So 11.5% in the proportion. This is a percentage. To get proportion, it'll be 0.115, right? And P2, which is right-handed, is 0.885. Perfect. So now that we got this, what will be the alternative hypothesis? Think about it. Now, alternative hypothesis. Let's see. Okay, this will not equal to this, and this not equal to that. Now we can write that down, but we can just say either Pi, which is done in the PowerPoint, so know this thing is not equal to its specific value. So what this means, Pi can represent either 1 or 2. So P1 could not equal to its value, P2 could not equal to value, right? Perfect. So now that we did the null and alternate hypothesis, let's do the critical value. Now the critical value is the most easiest, right? When doing a critical value and you draw a chi-square distribution, chi-square distribution should look something like this. Perfect. Now when you always do this, this will always be a right tail test. You might ask what this means. A right tail test means that if your test statistic, which is the right of the critical value, which is this region here, you have to reject the null hypothesis. If it's in this region here, left of this critical value over here, what you're gonna find, we fail to reject it, right? So fail to reject. But now you must ask yourself, what is this critical value? To find this critical value, we have to use the tables, right? So first of all, the critical value, what will it be? So chi-squared. Now obviously to write this down, you write the degrees of freedom here. The degrees of freedom is equals to k minus 1. You did this last year, right? K represents the number of categories. Right-handed and left-handed, there are 2 categories. So 2 minus 1 is equals to 1. So degrees of freedom is 1. And what is the area to the right? They tell you it's a 10% significance level. That means the area to the right is 0.1, right? That's easy. So we're looking for this. The chi-squared in the table that has a degrees of freedom 1 with 0.1 on the right. So let's go to the tables. 0.1 to the right is over here. to 0.1, but degrees of freedom is 1. So it's this one over here, 2.7, 2.7, right? 2.71 rounded to 2 decimal places. We'll do 2 decimal places for now. So 2.71. So this value over here is 2.71. So now we're to find the test statistic. So this is where it comes interesting. Because remember, to find a test statistic, and if it's on the right now, we'll reject the null. If it's left, we'll fail to reject it, right? So to find a test statistic, we first have to do a table, right? So let's draw a table over here. This stands for right hand people, this stands for left hand people, this is the total column. This is the observed column, this is the expected column, and this is the table. So you see how I did it? Whatever categories I got, I put here, I put the total, and then whatever categories, well, no, actually observed and expected will always be there. Now, first, the easiest one to do over here is the observed. 71 is right-handed, observed. Left hand, 10, observed. Now 81 is the total amount of people. Now this total over here is going to be also 81, right? Just to know. Now you might ask how to find the expected. You see over here they're saying here 85% was right-handed. 88.5% was right-handed. So all you need to do is say this. In the right-hand column, to get what's this, you say 88.5 times 81%. Because we need to know out of 81 people, this proportion, what is it? 88.5% of 81. So, if you go to your calculators, so let's see. So we're looking for 88.5%. Okay, let's see. So 88.5 times, let's see, 81%. That is 71.69. So on the right here, 71.69. And then for the left, we said 11.5. So 11.5 times, what is the total number of people conducted now in the observed is 81. Don't forget percent. That is equals to 9.32. 9.32. And there we go. Now you might say this, we're dealing with people, so why we got decimals over here? Should we round up? Should we round down? Don't worry, this is statistics, so we need decimals to make this accurate. So now that we've got our table over here, a completed table, if I may add, we can now use the formula to find the test statistic. Now x with a 0 is basically test statistic. That's the symbol to do test statistic. The formula for this is O minus E all squared over E. Now O minus E or E minus O, you can do either way because it's squared, so it always result in a positive value, so it really doesn't matter. But what you're to do is this: go to two of your categories. So we have two categories, right and left, and do each one. So what is O minus E all squared over E of that category of the right? So basically what we're saying is this: 71, which is the observed, minus the expected, which is 71.69, all squared over the expected, which is 71.69. After we do the right hand, let's do the left. The left will be 10 minus 9.32 over 9.32. So you see how we're only doing it for that category, observed minus expected all squared over the expected. So can you see now all we have to do is get this test that I okay. So I have a very hard time pronouncing words, but it's fine. So in your calculator, let's see, 71 minus 71.69 all squared over 71.69. And don't forget, always it's for this category, right? There's two separate categories which you need to add. 10 minus 9.32 all squared over 9.32. And let's see what we get. 9.32 is equals to, okay, I got 0.0 0.06. Okay, 0.06. So 0.06. Now 0.06, this is the test statistic. So if we go over here right now, 0.06 will be, let's do a different color, will be over here. And which region is this? This is the fail to reject region. So now all we have to say is this. So to write this down, let's see, how can we write it? So first we have to make sense of what happened here, right? We can't just say fail to reject and be happy. No. We have to say that this over here, x0, which means the test statistic, is less than the chi-squared. So like basically saying it's less than this, which is 2.71, right? So yeah, this can be represented as that, or you can say it's less than 2, whatever you find better, right? So therefore you can say we fail to reject the null hypothesis, and you can say in favor of the alternate, right? But basically what we all said here, so what this means, we fail to reject it. It means we fail to reject this. So we don't reject it, we fail to reject. That's good, we accept it, that means, right? But don't say accept. We fail to reject means accept. So basically the predictions of the actual number, the predictions of the people with left-handed versus right-handed was actually accurate. They were actually good in predicting. So that's the conclusion, right? So they were actually good with the guesses. So that's how you do it. So remember, first step, find a critical value. Second step, test statistic. You need to draw a table. Use the formula for test statistic. You get the test statistic, which is over here. Put it on your graph you did earlier and see whether it's less than or greater than the critical value. And that's it for chai, or whatever you call it, goodness of fit test.